All right, so Unit 1, Lesson 4, Dividing Radicals, Part 1. So there's two parts to dividing. There's two different things we're going to deal with. Remember last time I kind of told you, we did a little bit of conjugate stuff last time. We're going to be using that in these two sections because we don't want radicals on the bottom. Okay, having radicals at the bottom is kind of being unsimplified or not, I don't know what the best way to say it is. They're just not in the best form. Okay, so in previous work we discovered that square rooting, we just talked about this today from your exit slip, root A over root B is the same as A over B under the root. Okay, we can use this rule to divide radicals in the form of here. Okay, so for example, just going right to the examples. So root 30 over root 6, we could just rewrite this. I'll rewrite it one time just for practice. It's 30 over 6 under the radical. So it's not 5, it's root 5. So this answer here is root 5 for A. Okay, then like with multiplication, yeah.
So you're saying that's the same thing as that. So root 30 over root 6 is the same thing.
Yes, right. These two are the same thing by our division rule. That is correct. Okay? All right, so this next one is like the same thing as multiplication. Remember we did multiplication, you multiplied the coefficients and you multiplied the radicals. So now you're going to divide the coefficients and you're going to divide the radicals. Okay? You guys know what coefficients means, right? Coefficients, the number in front.
Yep.
Okay? Just to refresh, because sometimes I forget even. 8 over 2 is 4. Root 21, cube root 21 over cube root 3. They are the same index. It's going to be cube root 7. So 4 cube root 7 there. All right, same thing here. This one, they don't go in evenly, but 15 over 10 can reduce to 3 over 2. Okay, 48 divided by 6 is root 8. Okay, when you see a root 8, you should think, I can break that down. Okay, I can break that down to 4 times 2, like we just did in our warm-up. The 4 came out. The 4 hits the 3. Because when you multiply 3 halves by 2, it's like that, right? You hit the top, hit the bottom with the 1. Whole number is always times the top. So it's going to be 6 over 2, which equals 3. Okay, I probably lost you, but the root 2 here stayed inside. I multiplied 3 times 2 to get 6. 6 divided by 2 is 3. Okay, kind of take your second to look at that, try to follow me. Okay, I'll kind of talk you through it one more time. 15 over 10 reduces to 3 halves. 48 divided by 6 is 8. Break the 8 down to 4 times 2. Pull the 4 out of the 2. 2 times 3 is 6. 6 over 2 is 3. The root 2 is left inside. All right. Okay. 4 over 12 reduces to 1/3. Root AB over root A. Well, if you're confused, let's just write it. What would you do with the A's there? You'd cancel them. So all you'd have is a root B. So then all you would have is root B over 3, because the root B would just slide to the top. But the 1/3 root B is fine as well. Those are both correct answers. Nope, doesn't matter to me. No. Okay. All right, example 2. Today is pretty much an example, so less investigations, less explaining, more just doing. So, all right, so simplify the numerator and the denominator, then divide. So what this wants you to do is it wants you to simplify, then divide. So 8 can be broken down to 4 times 2. 54 can be broken down to 9 times 6. Remember I say breaking down, we're looking for perfect squares. So this 4 comes out as a 2. So on the bottom I now have 6 root 2. Okay, and then the top, this comes out as a 3. 4 times 3 is 12. And I have a root 6. Now we can go and do what we were just doing the last section. Okay, because 8 doesn't go into 54. So you might have been like, well, I can't do it. Well, you can because you can break it down and then do it. Okay, so 12 divided by 6, 2. Root 6, root 2, root 3. end up? Okay. There's no coefficient down here, so it's just going to be an 8. So I just need to work on breaking these two down. Okay, 126. Biggest perfect square into that is 9 times 14. And then 112, is that 36? Nope, 16. 16 times 7 for the 112 is what you'd get to. And I am kind of going over the finding the perfect squares faster, just because I'm giving you a lesson, you know how to do that. It might take you a little bit longer, but again, that's totally fine. All right, the 9 comes out as a 3, so it hits the 8. 24 root 14 is on top. 16 comes out as a 4. 4 root 7 on bottom. And now we divide it out. 24 divided by 4 is 6. Root 14 over root 7 is root 2. All right. Okay, again, going to break them down first, and then we'll divide. So 162, I'm going to go with 81 and 2. And then 128, which one do we want for that one? 64 and 2. Should have got that one. Okay. 81 comes out of the 9. It gives me a 90 on top. Root 2, or cube root 2. 64 comes out as an 8. Gives me 20 times 8, which is 160. Gives me a cube root 2. So anything over itself, what?
Oh, wait. That's a cube root.
Cube root, I put. Yeah, that's right. Oh, yeah. Thank you. All right, so, got ahead of myself. Let's pick this up here. Good call. Thank you. Start that over. So yeah, it's a cube root. So I was obviously I was square rooting. So is that going to be? Do I want 27 there now, or do I still want? Yeah, I want 27 and 6. So this goes to 27 and 6. I still want the 64 though, and 2. They just come out differently. Thanks. Okay, so 27 comes out as a 3. Excuse me. 64 comes out as a 4. So that's going to give me 30 cube root 6 over 80 cube root 2. Now we good? Yeah. Okay. These simplify to 3 over 8. This simplifies to root 3, cube root 3. Like that. Okay, we got one more, and then we're just going to learn how to rationalize the denominator, and then we'll be done. Okay. Okay, so divide each term in the numerator by the denominator and simplify. So we're going to divide them first and then simplify. So we can do them piece by piece, because when we're doing fractions, remember, it's like this can be also written as 3 fractions. We can write this as root 24 over root 6 plus root 48 over root 6 minus root 108 over root 6. That's the same thing. Okay, so I'm just going to do that real quick. So root 24 over root 6, root 4. We'll change that in a second. Root 48 over root 6 is root 8. 108 and 6 is, let's see, what's that get us to? 90, 33? No. Is it 33? No, it's 18. Oh, yeah, gotcha. Yeah, thanks. I was not thinking at all. Okay, so now what we're going to do is I'm going to break down the 8 and the 18. The 4 is just going to be a what? 2, so square root 4 is 2. This comes out to 2 root 2. This comes out to 3 root 2. Okay, I got one more step we can do. There's one more. Yeah, subtract the common radical. That's the last step. I can subtract the like terms. 2 minus 3, which just gives me a negative root 2, because it's a negative 1. You can put a negative 1 up there if you want, remember? They're not going to in the book. Okay, it's just negative 1 root 2. Make sure I'm good still, so I've already had a mistake. Yep. All right, last page here. All right, so rationalize the denominator. Again, to have things in simplest form, we don't want radicals on the bottom. Okay, and that's what it's talking about up here. Okay, so the process of eliminating the denominator is called rationalizing. So we're going to do that right now. Okay, so when we're doing, like, think about fractions. If we want to change something in a fraction, like one of the common denominator, what do? When we're trying to get the bottom different, what do we do in common denominator? Like, just think about just fraction work. Yeah, times it by stuff. Yeah, exactly. No, that's right. Times it by stuff. We times it, but whenever you times the bottom, you would times the what? The top, because then that means you're not changing the number. Okay, that's the important thing. You can't think when I'm doing this that I'm changing the number. If you put this in your calculator, and then what I give you in the calculator, you're going to have the same thing. Okay, so how do you rationalize? Well, what would you think would be the best thing to multiply root 13 by to get rid of it being a radical? What do? What's that? Square of 13, exactly. The same thing it is. Because when you multiply root 13 times root 13, it equals just 13. So to rationalize, we do this. To top and bottom. Okay? So then that gives me a root 13 on top and just a 13 on bottom. And now it meets the code or the standard. There's no root on the bottom now. Okay? So we just rationalized it. Is there any questions with that? Right, that's not simplified completely. If you have a radical on the bottom, you're not all the way there. Okay? All right, so the next one, root 2. Because again, anything over itself is 1, so we're timesing by 1, so nothing's changing. Root 5 times root 2 by the multiplication is root 10 over 2. And it's rationalized. Okay, don't worry about this negative. They're just putting there to mess with you. Just focus the root 6, the problem, not the negative. Negative can be down there. We don't have to times by negative root 6. Okay, so let's just go. Where'd that come from? Oh, it's fine. It's on the way. Okay, so let's just go root 6 and root 6. And that's going to give me a root 12. Whoops. Root 12 over negative 6. And then here, we're still not quite there because we can break the 12 down. The 12, we broke it down to 4 and the 3. So I get 2 root 3 over negative 6. And lastly, I can reduce that fraction of 2 over 6 to 1/3. We'll make it negative. So right here is the full simplified complete answer there. There's a lot of steps there. If you have questions, just speak up. Okay. All right, this one here, root 3. It's going to get you root 60 on top. It's going to get you just a 3 on bottom. Then we're going to see, can I get 60 any lower? So anything that goes into 60 is a perfect square. 15 times 4. Okay, 15 times 4. 4 comes out as a 2. 2 root 15 over 3. Can't reduce anymore, you're done. Okay, good. Okay, 2 more example sets. Keep hanging in there. All right. So this one, I'm kind of mixing things up a little bit. So they have a coefficient down there. Again, we don't care about the 3. The 3 is not an issue. The only thing that's an issue is the root 7. Okay? So I'm still going to stay with root 7, root 7. That's all that's all that I'm worried about. Okay? Okay, so doing that, I'm going to get 7 root 7 on top. And on bottom, I'm going to get root 7 has root 7 times the 3. I'm going to get 21. Okay, because they still multiply. It's still there. Okay? And so then, now this will reduce to 1/3 root 7. 7 over 21 is equivalent to 1/3. Okay, see a little bit of confused faces. We got any concerns? It's just Friday. Just want to get out of here. All right, so this one we're going to write as this because it's just easiest for us to see what to do. Because remember, we can do that with division. It goes top and to bottom. So I'm going to hit the top and bottom with root 5. Okay, that's going to give me root 90 over, not root anymore, over 5. What does 90 break down to? 9 and 10. Good. Comes out as a 3. So you get 3 root 10 over 5. And tomorrow we'll be doing the same thing but with the conjugate. Remember we talked about the conjugate yesterday, or not tomorrow, you won't be here, Monday. We'll be doing that's last pieces with the conjugate. Okay, all right, last 2 questions here, 1 and 2. All right, let's break, I'm going to break the 72 down first. Just seems easy. Do you have a question? Oh, sorry. Sure. Okay, yeah, sorry. So, did you see 9 times 10, right? The 9 comes out as a 3. Because square root of 9 is 3, so that's right there, and the 5 was already there. And the 10 was left inside. Okay? All right, so on C, I'm going to break, yeah? 10 over 5. Oh, this isn't a radical, though. So if they were, yes, but this is a number that's a radical. Okay, good? I don't think we can put her back there anymore. Okay? All right, back to what I was doing here. We good now? See? Okay, so take 4, comes out of the 2. Take 36, comes out of the 6. 3 times 2 is 6 on top with a root 3 right there. Or this is what's left inside. That's a 6 there. It's a 2 left inside. See, if since I did that, it made my life a lot easier. Okay? Because now the 6's will cancel. Yeah. Start over? Sure. Sorry. Did you get distracted? All right. Fair enough. Let's start over. All right. So I'm going to break these down first because I noticed that 12 and 72 have perfect squares in them. So I'm breaking this down to 4 times 3 and 36 times 2. Okay? And so then I take the 4 out. It comes out as a 2. Okay? The 3 is going to be left inside. I'm going to take the 36 out as a 6. The 2 is going to be left inside. So the top, I'm going to have 2 times 3, which is 6 root 3. 6 came out, and a root 2. We good? Okay? Perfect. No problems doing that over again. 6's cancel. Root 3 over 2, I want to get rid of the root in the bottom. So I'm going to get root 6 over 2 will be your final answer. Root 2 times 2 is 2. Root 3 times root 2 is root 6. All right, one more. What's that? Oh, yeah, sure, sorry. Go ahead. Give you some time. Gives me time to get a drink here. Good? Okay. Hold it together back there. Hold it together. All right, simplify the radical expression, last one. So it says rationalize the denominator first, and it says divide the numerator and denominator. So it wants us to do both ways. So it wants us to rationalize first, and then just divide first. And I'm going to ruin the big surprise. It's going to be the same answer. Okay. So, all right. So first thing, rationalize first. So we're going to go 3 root 18 minus root 12 all over root 2. So we're going to go root 2 to top and bottom. Remember, when you do the top and bottom, if there's two things up here, it has to hit both things. Okay, so we're rationalizing the bottom. So did root 2 to top and bottom. The root 2 has to hit both things on top. We have two things on top. Okay, so that's going to give me 3 root 36 minus root 24 all over just a 2, because that's how we rationalize. Okay, we good? 36 is a 6, with a 3 there's an 18. That breaks down to 4 times 6, comes out as a 2 root 6, all over 2. You can go ahead and cancel one more time and get 18 over 2 is 9 minus root 6 is what the final thing would be. So what happens here is 18 divided by 2 is 9. 2 over 2 cancels, so you just have the root 6 and the 2 on the bottom has been eliminated. Okay, so that is by doing the rationalizing first. Okay, now let's do it by, yeah, go ahead.
Divide 18 by 2 and then negative 2 by 2.
Right. Yeah, because it's like, remember, it's like two fractions.
Yeah. Okay. All right.
Okay. Okay, so now if I divide first, the root 2 goes here and the root 2 goes here. So root 18 divided by root 2 is root 9. Root 12 divided by root 2 is root 6. So you kind of see this is quite a bit, oh, that's pretty good grammar. This is a lot faster. Okay, this doesn't take as long. That makes a 3, so 3 times 3 is 9. That's just root 6. So if you can divide it out first, it makes your life a little bit easier. All right. Okay, that is it. So what I do want